Good morning, students. I am Katyayani, lecturer in Electronics and Communications, Department of Collegiate and Technical Education. Today I will start with the 17th session of Unit 2, Instruction Set and Assembly Programming of 8051. The course is Microcontroller and its Applications of 3rd semester diploma. Course code is 15MC34T and the program is Mechatronics. So let's have a quick recap on the previous session that what we have discussed. So in the previous session we have discussed few programs on branch and looping instructions, that is program to search for a given number in an array of numbers and program to transfer a block of data from external to internal RAM. So in this session we will be discussing the program to find the smallest number in an array of numbers stored in an external RAM. So the program is programmed to find the smallest number in an array of numbers stored in external RAM. So what is the requirements? So it is external RAM. So external RAM. So it is, we are starting with 80. It is our preference because they have not mentioned which memory location the data is present. So with our preference we are taking 8000H to 8003H and we are planning to take 4 datas. So out of these 4 data, we are planning to find the smallest number. So out of these 4 data, 6, 7, 7 and 3, what is the smallest? That is 3. So that data has to be displayed at the memory location 50H. So this is the preliminary setup. So we'll start with the origin. So the data pointer is at which memory location? 8000H. So we are taking the move dptr comma immediate 8000H. This is the external memory pointer. And then internal memory pointer is located at 50H. So hence I am planning to take the highest number, that is we have to find the smallest number. So I will set it initially with the larger number. What is the maximum large number? 8 bit value, that is 1 byte value that can be given, that is FFH. So that is I have taken the maximum value at the location 50H initially. And then what is the count? How many locations we have to check? 4 locations. That is why I am taking count as 4 in the register R1. So now what I have to do? So I have to take the data. First I have to take this data. The contents of this has to be taken by the accumulator. So move XA comma at DPTR takes the contents of external memory locations into accumulator. Now I will compare that using CJNE instruction. So here we are comparing and also checking whether it is larger or smaller. So that is performed like this. So first it will check what is the data in accumulator. According to this, data in accumulator initially will be 06H. First data will be extracted. Data in 50H will be initially what we have given, FFH. So A is having 06H and 50H contents is FFH. Are they equal? No, they are not equal. So when they are not equal, then it goes to check. If they are equal, what is the use is that we don't need to exchange. If both the same data, both the locations have the same data, that is accumulator is also having 5 and 50H contents is also 5, no need to perform exchange. So that is why there is no change. So hence no change is performed. So otherwise we have to exchange the contents based on whether it is a larger or a smaller number. So next we will check. They are not equal. As of now, they are not equal. So now we will check the carry flag. Whether we have to exchange them or the found number itself is the smallest number. So we will check jump no carry to no change. Do we get carry here? A is how much? 06H and 50H contents is FFH. Do we get carry? Here subtraction will happen from A contents of accumulator, that is 6 minus FFH. Do we get carry? Yes. Carry flag will be set. So whenever this carry flag is set, what happens? No need to exchange. Jump no carry to no change. But here the carry has occurred. So carry has occurred means we have to change. So that is move 50H comma A. So that is FFH is not the smallest number. Which is the smallest number as of now? Contents of accumulator, that is 06H is the smallest number. That will be copied into the memory location 50H. As of now, from the first element, we have found that 06H is the smallest number. Now, we have to check with the next number. It will go to increment DPTR. It will point to the next. And since we have checked with one number, so what we have to do? We have to decrement the count value. So DJNZ R1 comma back, it will decrement 4 to 3 and check whether they are equal to 0. If not, then it goes back. Then again we will take the next data into accumulator. The next data is 07H. Now accumulator is having 07H. What is the contents in 50H? It is 06H. Compare 07 and 06. 7 minus 6. Carry flag is set? No. Carry flag is not set. Are they equal? No. So first we will check whether they are equal. They are not equal. So hence go to check. So here is carry flag set? No. Carry flag is not set. Jump no carry to no change. No change because as if you compare 6 and 7, 6 itself is the smallest. No need to exchange. So hence there is no change. Again we will perform the next increment DPTR. We will go with the next memory location. This process will be continued till the count is reached. So as of now, compared with 6 and 7, which is the smallest number we have found in memory location? 6H. It will similarly perform compare with all the memory locations and it will find the smallest value. Let us check this with the program. So what is my initial requirement? So I will set the origin. Then what is my external memory location? Move DPTR, comma, immediate. What is the external memory location that I am planning to take? That is 8000H. 8000H. The next memory pointer is 50H. So that is the memory location 50H. I am planning to have the highest value in that in order to find the smallest value. I will be loading with this. And next I will load with the count. How many locations I am going to check? I am going to check how many locations? 4 locations. Next is I will take the data, external data into accumulator. So what is the instruction? Move X, A comma at DPTR. From external memory, the contents will be moved to accumulator. Now what I have to do? I have to compare this accumulator contents with the 50H memory location contents. Jump not equal. If they are not equal to some label, they have to jump. Let me take LEB. They have to go. If they are not equal. If they are equal, what they have to do? Is jump to some other location. No change. No change. So here also let me take change. It's okay. So next is now compare and jump not equal. Not equal means they have to come to another label, that is LEB. They are not equal. Now they have to check for carry flag. Jump no carry. If there is no carry means no carry means no need to change. If there is a carry means the smallest number should be loaded to 50H. Smallest number should be loaded to 50H. And here comes the no change loop. And now we have done with the first cell. The next is we have to go to the next memory location. So hence we will go to increment dptr, and then what we have to do? Decrement the count value. So djnz, it is r1 comma back, and then it is here. So where should go the back loop go to? Yes, it should go here where it extracts the data from the external memory. It is back. So let us save. Go to the debugger session. So external memory is at which location? 8000H, and internal where it is displaying? It is displaying the smallest element at 50H memory location. So now 8000H. So what is the count value that we are taking? 4 elements. So give some 4 elements: 07, 23, 56 and 4. Which is the smallest of this? 4 is the smallest. That has to be displayed here. So first let us take here. So first the external memory location will be allotted into DPTR register, and then 50H will be loaded with the maximum value. This is the 50H, maximum value will be loaded initially. Next R1 will be loaded with the count value. Next accumulator will get the first data from the external memory 07. Now we will perform compare operation between the contents of accumulator, that is 07, and 50H. What is the location 50H has? FFH. Compare 7 and FF. Will carry flag be set? Yes. So what happens? Are they equal? No. So first it will compare. So are they equal? No. It goes to label. And here is carry flag set? Yes, carry flag set. So what it is to do? It has to do the exchange operation. That is 50H should be loaded with the value 07H. So with the first comparison we have found that 07H is the smallest number. So first comparison is done. So we have to go to the next memory location data, that is pointer, that is 8001H. Next we will decrement the count to 4 to 3 since once comparison is done. So similarly next we will take the next external memory data, that is 23H. 23H. Is 23H greater, smaller, or 07 is smaller? 07 itself is the smaller, so it should not be changed. Let us see. They will compare. So compare 23 and 07. Will carry flag be set? No. So hence, see, are they equal? No. So if they are not equal, it goes to label. At label, it will check jump no carry. No carry? Yes. So no change. It goes to no change. So at no change, it goes to the next memory location. So that is next pointer. So 8002. And next count should be decremented. Next we will take the next data, that is 56. We will compare. After comparing we found that carry flag will not be set. So hence DPTR this content will remain the 7 itself, and again will DPTR go to the next memory location, and the count will be loaded with the decremented with 1, and now the accumulator content will be loaded with 4. So now compare 4 and 7. Carry flag will be set? Yes. If carry flag is set, what happens? It exchanges. It exchanges. So that is, it changes. That is, the 7 should be changed to 4. So what happens here? So is carry flag set? Yes, carry will be set. So let us see what happens. So now it will check for jump no carry as carry flag is set. So it will exchange that value. So what happens? Now 7 is replaced by 4. So next count will be decremented. The DPTR will be incremented to point to the next memory location no matter, and count is 0. So now count is 0, hence DJNZ 0. Is it equals to 0? Yes, decrement R1 is 0. So hence it will not go to the back loop. It will go to the end statement of this instruction. So if we give these data, which is the smallest of these data, 4. So 4 is displayed at the internal memory location, and the data is present at the external memory location, and at internal memory location we are displaying the result. So what are the session islands? So we have used CJNE compare and jump not equal instruction, and DJNZ, that is decrement and jump not 0, move X, that is move data from external memory location. So what happens in CJNE instruction? It will compare, and if they are not equal, it goes to the label. And also again we have checked the updation of the carry flag. If carry flag is set, some operation has to be performed. If carry flag is not set, then some operation has to be performed. So in this, if you want to find the largest number of an array in the same process, what do you have to do? Yes, you will just change this to 0, 0, 0, 0, 0, and then instead of jump no carry, you have to set it to carry. Only two changes. You will set this to 0, 0, and then instead of jump no carry, you will set this to carry. So then you can find the largest number in an array of numbers. So let us check that. So here we have to change this to 00H, and just change this contents to, instead of jump carry, you make it jump no carry, you make it as jump carry. So then you will be finding the largest number. So let us take, so let me give the inputs. So inputs, let it be at some data 34, 08, 45, 06. What is the largest of these? It is 45. So let us run this program and check the output. So 45H is the largest number. So this is the largest number out of the array. So the largest number is displayed here. So we have understood the concept of both smallest number and also the largest number. So let us start with MCQs of session 17. Multiple choice questions of session 17. If accumulator is equals to 33H, what happens to the contents of accumulator after execution of XRL A, immediate 0 FFH instruction? Option A, accumulator is equals to CCH. Option B, accumulator is equals to 33H. Option C, accumulator is equals to FFH. Option D, accumulator is equals to 00H. So what happens? So yes, XORL operation. Let us analyze this. It is perform XORL operation. So let us take here. So what is that they have given? Accumulator is equals to 33H and XORL with FFH. Accumulator is equals to 33H and XORL with FFH. So accumulator is 33H, means it is 0011 0011. FFH is 11111 and 1111. So what operation you have to perform? XOR operation. So what happens if you perform XOR operation? 0 XOR with 1, it is 1. 0 XOR with 1, it is 1. 1 XOR with 1, it is 0. 1 XOR 1, it is 0. 0 XOR with 1 it is 1. 0 XOR with 1 it is 1. 1 XOR with 1 it is 0. And 1 XOR 1 it is 0. So what is the answer? 1 1 0 0. 1 1 0 0 is 8, 9, 10, 11, 12. 12 means it is C. So here also it is 12, it is C. CCH. So what is the contents of accumulator? It is CCH. So option A is the correct answer, that is CCH. So next, second question. If R naught is equals to 36H and contents of 36H is equals to 09H, what is the contents of R naught and contents of 36H after execution of increment at R naught instruction? Option A, R naught is equals to 36H and contents of 36H is equals to 0AH. Option B, R naught is equals to 37H and contents of 36H is 0AH. C, R naught is equals to 36H and contents of 36H is equals to 10H. Option D, R naught is equals to 37H and contents of 36H is 10H. So what they have given? R naught is equals to 36H and contents of 36H is 09H. And next, what do you have to perform? Increment at R naught. Increment at R naught. At R naught means contents of this should be incremented. So that is 09H. If increment 09H, what happens? It is 0AH. So R naught contents remains the same, but contents of 36H will be incremented to A. So what is the correct answer? Option A is the correct answer. So that is R naught is 36H and contents of 36H is 0AH. Next question. If R naught is equals to 50H and contents of 50H is 30H, what is the contents of R naught and contents of 50H after execution of decrement at R naught? So what we are performing here? We are performing decrement at R naught. So R naught is 50H and contents of 50H is 30H. Decrement at R naught. At R naught. You are going to, this is the data. You are going to decrement that. If you decrement that, what happens? Option A, R naught is equal to 4FH and contents of 50H is 2FH. Option B, R naught is equal to 50H and contents of 50H is 2FH. Option C, R naught is 49H and contents of 50H is 29H. D, R naught is 50H and contents of 50H is 29H. What is the answer? Yes, you have to decrement the contents of R naught appointed by memory location or not. That is 30. 30 will be decremented to, if you decrement 30, it is 2FH. So, but what happens to the R naught? R naught remains the same. So, R naught is equals to 50H and contents of 50H is 2FH is the correct answer. That is option B is the correct answer. Fourth question. What is the contents of accumulator register after execution of following code? Origin, start with origin. Move A, immediate 55H. Set bit carry. Rotate left through carry accumulator. End. Option A 55H, option B ABH, option C AAH, option D BAH. Answer. Let's analyze. What they have given? So A is 55H and then they have given carry is set. What is the operation that they are performing? Rotate left through carry accumulator. So that is rotate left through carry operation is performed. So what happens? So 55H, how will you write 55H? 55H is, how will you write 55H? It is 0101 0101. So what is the operation that you are performing? Rotate left through carry. So carry will be rotated. So rotate left through carry. So 1. So you are going to rotate left. So just you perform left rotation operation. So you just shift this left. So 0 will come to the carry's position and then 1 comes to MSB, again 0, again 1, again 0. Again shift it. Again it is 1, 0, 1. Again now This will come back here, rotate left through carry. So it will come back here. So what is the answer? It is 1010 1011. 8 plus 2 it is 10. 8 plus 2 plus 1 it is 11. 10 is A, 11 is B. So answer is AB. AB. So answer is option B, ABH. Fifth question. If A is equals to 77H, what happens to the contents of accumulator register after execution of ORL A, immediate 0 FFH instruction? Option A, accumulator is equals to 77H. Option B, accumulator is equals to FFH. Option C, accumulator is equals to 00H. Option D, accumulator is equals to F7H. So what is the answer? We are performing OR operation. If any one of the bit is 1, the output will always be 1 in case of OR operation. So, the correct answer is option B, FFH. Sixth question. What is the location value of R0 and the contents at that place? Move 45H, immediate 4FH. Move R0, 45H. Increment R0. Move at R0, immediate 30H. Option A, 45H, 4F. Option B, 50H, 30H. Option C, 30H, 50H. Option D, 50H, 45H. Let us analyze this. What is that they have given? Move 45H, immediate 4FH. 45H is direct addressing mode. So it is contents that will be equal to immediate data, that is 4FH. First instruction. The next instruction, move R0, 45H. This is direct address. So what happens? So R0 will be copied with contents of that memory location, that is nothing but 4FH. The next is increment R0. What happens? Next is increment R0. What is R0? R0 is 4F. Increment R0. So R0 will be equals to 50H. What is next instruction? Move at R0, immediate 30. At R0, immediate 30. What is in at R0? At R0 is, that is contents of 50H will be equals to immediate data, that is 30H. So what is the question now? What is the location value of R0 and contents at that place? What is the location value of R0? It is 50H and its contents is 30H. So what is the answer? 50H and 30H. That is option B is the correct answer. So the next question. Option B is the correct answer. What is the result at A, R1? Move A, immediate 78H. Move R1, immediate 59H. Move 59H, immediate 43H. XCHD A, at R1. Option A, 73H, 59H. Option B, 48H, 59H. Option C, 78H, 43H. Option D, 43H, 78H. So let us analyze this. Move A, immediate 78H. Move A, immediate 78H. Next, R1 is having 59H. R1 is loaded with 59H. Next, 59H is a direct addressing mode. 59H contents is immediate data 43H. 59H contents will be 43H. XCHD A, at R1. XCHD A, at R1. XCHD A, at R1. What happens now? So exchange this operation will be performed between accumulator 78 and at R1, that is 43H. So what happens after execution of this? A will be 73. This lower nibble will be exchanged, that is 73H in the accumulator. And what is the other question that they have asked? R1. What will be the contents of R1? R1 doesn't change, it remains the same, that is R1 is equals to 59H. So answer is 73H and 59H. 73H and 59H. It is present in option A, 73H and 59H. Option A is the correct answer. These are the solutions for the MCQs, and thank you.